Index of Refraction by Janki Patel
and Baird Alexander II. Refraction. Refraction is the change in direction to waves on the boundary between two different mediums.
To better understand index of refraction, let's use a question. Glass has an index of refraction of 1.52. A. What is the speed of light in glass? And B. How far does light travel in 120 seconds?
To answer the question, we need to use the index of refraction equation. The index of refraction equation is N equals C over V.
C is the speed of light in a vacuum, which is 3 times 10 to the 8th meters per second. V is the velocity of the light in the medium. And N is the index of refraction.
N is the index of refraction, which is 1.52. C is the speed of light in a vacuum, which is 3 times 10 to the 8th power meters per second. And V is the velocity, which we don't have, meters per second.
Plugging in the numbers for the equation, N equals 1.52, which equals C, 3 times 10 to the 8th divided by V. Rearranging the equation, we get V equals 3 times 10 to the 8th divided by 1.52. Solving this, we get a velocity of 1.97 times 10 to the 8th meters per second.
This is a diagram of how the light travels through the glass with the index of refraction of 1.52.
To find the answer to the second question, which is how far does light travel in 120 seconds, we use the equation delta x equals v times t. Delta x is the displacement, v is the velocity, and t is the time. For this question, delta x is unknown, v equals 1.97 times 10 to the 8th meters per second, and t is 120 seconds.
To find the distance or displacement, we had to multiply 1.97 times 10 to the 8th power times 120 seconds. The total displacement equals 2.36 times 10 to the 10th power meters.
Recapping the answers of the question, what is the speed of light in a glass, with index of refraction of 1.52, we get the answer of 1.97 times 10 to the 8th meters per second.
Recapping the answer for question B, how far does light travel in 120 seconds? We got the final answer of 2.36 times 10 to the 10th power meters.
Thank you!